front of you. One says 424 and one says 428. We're looking at the 424. Okay, so this is where we're going to start talking about rational expressions, rational functions. So first, let's define what that even is. So a rational expression is a quotient. Okay, remember, oh my God. If this pen already isn't working, we've just started the day. Let me try and change the battery in it real quick, see if that's it. But go ahead and write quotient there in that blank. Okay, so remember, a quotient is the answer you get when you divide. So we talked about last week when we were doing the synthetic division, we said, remember, you do the dividend divided by the divisor, and then it equals the quotient. So quotient is the answer when you divide. Okay, so when I divide, I get a quotient. Oh, this is the right size battery. Okay, so when we, it's the quotient of two polynomial expressions. Okay, and to simplify rational expressions, okay, there's these three steps. Okay, here we go. Sorry about that. All right, so step one is once all of your expressions have the same denominator. Okay, so if we're adding or subtracting multiple rational expressions, okay, we have to have the same denominator. Okay, adding and subtracting fractions requires a common denominator. Okay, if that's something you want to write out here to the side to remind yourself, if you add or subtract fractions, you need common denominator. And rational expressions are fractions, okay? They just have expressions in the numerator and denominator, not just numbers. The notes are over here if you need to come grab them. The notes. All right, okay, so we need the same denominator to be able to add or subtract. Okay, so after you get a common denominator, then you're going to simplify. Okay, that means you're going to combine like terms from the numerator. Okay, if you forget the terminology, if you struggle with the vocab, okay, remember the numerator, that's the top. Okay, so the denominator is supposed to be outlined in blue. Okay, you need the same denominator, and the denominator is the bottom. So you get a common denominator, and then you combine like terms across the numerators. Okay, if you can factor numerator or denominator, if there's anything that can be factored, you want to factor, because then you may be able to simplify it further by reducing. Okay, so you simplify the expression and cancel out any common factors within the numerator and denominator. Okay, but to be able to reduce, you must factor first. So you factor and reduce what you can. Okay, reduce common factors. That means they have to be exactly the same factors in both the top and the bottom. Okay, so we're going to try this. Okay, it's written in words up here, the steps, but now let's actually apply that. Okay, so in this first one, are my denominators the same? They are exactly the same. I already have my common denominator. So I don't need to do anything special for step 1. I have a common denominator. So now I simply need to combine like terms in the numerators. Okay, so my denominator stays that common denominator that is there. Okay, but now I'm going to put the 6 and the 1 together in the numerator. Now, most of you probably don't need to write this step showing 6 plus 1, but I just want to show it for our notes so you can see we're combining these two rational expressions into one by adding them with a common denominator. So then you can go ahead and write 6 plus 1 as 7. So you've got 7 over x squared, or 7 over 7x squared. So what happens with those 7s? Those reduce. 7 over 7 is just a 1. Okay, so this reduces down or simplifies down to just 1 over x squared. In this second one, do we have a common denominator already? We do. 4x plus 1 is our common denominator. So I'm going to go ahead and write that denominator, 4x plus 1. And in the numerator, I'm going to write everything from both. So this is 7 minus -2. Over here, it was a plus. Okay, this one's a minus, so I have minus -2. What happens when you minus a negative? So 7 plus 2 is 9. And then 4x plus 1. Now in this one, we have an expression in the denominator, not just a monomial. This was a single term, a coefficient, and a variable. Here we have a plus or a minus sign, so it's an expression. So these tend to be where they get more complex and people make mistakes with reducing. Let's pretend this had been a 4. You could not reduce the 4 over the 4x because in the denominator, the 4x is attached to this plus 1. Okay, so you have to be careful. But here there is nothing to reduce. That's as far as we can take it. All right. Here's another one. Already has a common denominator. So our common denominator is 3x plus 3. We are doing 4 plus 3 in the numerator. So we have 7 over 3x plus 3. Now, I can't simplify this any further, but this one can be factored. Lindsay? Thank you. That is not a common denominator. I misread that. Good catch. One of those has a plus 3, one of them has a plus 2. I tried to move too quickly. Okay. So this one is not a common denominator. I'm gonna circle or highlight that. So we're going to just say for now, because we're just focusing on real basic ones in this first set of notes. We're going to get into when they're not the same later in the notes. Man, if I could spell, y'all, it is for sure Monday. Denominator. Okay, so we're just going to move on from that one for now. Okay, we'll later in the notes, we'll do some and show how do we do this when they're not the same. So do be careful, because if they're not a common denominator, you can't just combine them like we've been doing. Okay, now this one, they are exactly the same. 5x minus 3, 5x minus 3. So our denominator is 5x minus 3. Okay, our numerator is going to be -8 plus -5, which would be -13. 5x minus 3 does not factor. There's nothing to reduce here. That's as much as I can do. So far, so good? Okay, so on this one, we're starting real basic. Just make sure, are the denominators the same? And if they are, let's combine. So now this one, we do have a common denominator, but now our numerators get a little more complex. So we've got 7x cubed as our common denominator. But now we've got expressions up here in the numerators, not just monomials. So I've got negative 3x minus 2, and then it's being added. So when you're adding something, that doesn't change the sign. So we're adding negative 2x plus 4. So you can just write minus 2x plus 4. If you want to put a plus sign here, you can, but you're adding a negative, so it's just going to stay a minus. So that my plus sign's not totally necessary here. So in my numerator, now I'm going to combine like terms. So I've got negative 3x and negative 2x. So that's negative 5x. And then I've got negative 2 plus 4. So that's plus 2. And then that's all still over my common denominator of 7x cubed. And there is nothing to factor in either the numerator or the denominator. That's as much as I can do. Okay, so here again, 4x minus 5 is the denominator for both of these. So that's going to stay my common denominator. And in the numerator, I'm going to write the first expression. Now, again, it's a plus, so that's not going to change any of the signs. So I can just write negative 5x minus 8. And I'm going to combine like terms again. Okay, so negative 3x and negative 5x is negative 8x. And negative 8 and positive 6 would be minus 2. And this is all still over my common denominator of 4x minus 5. Now, I can technically factor that numerator. There's a negative 2 that you could pull out a GCF. So if I divided out a negative 2 from the numerator, that would leave me with 4x plus 1. And in my denominator, there's no GCF. So it didn't change anything. I wasn't able to reduce, but you want to make sure if you can factor that you do so that you can check. Now, what I was left with, is it the same as the factor in the denominator? If it was, we'd be able to reduce. These both have 4x, but this one has a plus 1 and this one has a minus 5. So they are not the same. I cannot reduce anything here. So you can just leave it like this. Or you could have left it like this since nothing reduced once you factored. Okay. All right. Now these next two are same concept, but this time we have a minus sign. And since we have expressions in the numerator, this is going to be a little bit different. So we have our common denominator. Now this time our first expression is x plus 1. But this minus, isn't it going to change all the signs of the expression that we're subtracting? Minus, and then negative 4x minus 5 is what's being subtracted. So you can write it like this and then show the distribution here. Or some of you right here may just go ahead and show that and save yourself a step of writing. Okay, so wherever you want to do that distribution from the original equation or once you combine it, it doesn't matter. But that's going to change it to be a plus 4x plus 5, all still over 9x squared. So then I'll combine my like terms. So x and 4x is 5x. A positive 1 and a positive 5 is a plus 6. And my common denominator is still 9x squared. Nothing to factor. That's as much as I can do. But I combine those two rational expressions that were being subtracted. The difference of these two rational expressions is 5x plus 6 over 9x squared. Okay, so I'm going to do my distributing of the negative here. That's going to change that to a plus and a plus. So when I combine this to a single quotient or a single ratio, however you want to think of it. I've got 6x plus 2 as my denominator. And then I've got the 7x minus 3 from the first numerator. And then because of that minus, it's going to become plus x plus 8. And now I'm going to combine like terms. 7x plus x is 8x. And negative 3 and positive 8 would be plus 5. And my common denominator is still 6x plus 2. Now I could technically factor the 6x plus 2. I could factor out a 2, which would leave me with 3x plus 1. But again, that's not a factor that I see in the numerator. I can't factor the numerator, so it doesn't change. So you could write it like this with the denominator factored, or you could have left the denominator as 6x plus 2. That would be all right as well. Okay, so those are the real basic adding and subtracting rational functions when the denominators are already common. The front was the most basic because the numerators were all just numbers. Okay, so it was real simple, just combine the like terms in the numerator. But here on the back, when the numerators are expressions, okay, if it's addition, you just combine like terms in the numerator. But if it's subtraction, you have to distribute the negative first and then combine those like terms. Questions so far? Okay, so that was it for that note page that says 424. Okay, that was short and sweet. That's why we're combining these two today. Okay, so I'm going to go ahead and, if you're watching this as a video, I'm going to stop this video. You can go find the 428 video.